Hi guys, welcome to Deep Diver. Today we will dive into Golang and explore variables. Before discussing the syntax, techniques and best practices related with variables, let us first go through some concepts and build the right foundation. The first concept I want to discuss is statically typed language versus dynamically typed language. Most programming language can be classified either as statically typed or dynamically typed depending on when the type checking happens. Depending on when the type checking happens. So if the type checking happens at compile time, the language is called statically typed. If the type checking happens at runtime, language is called dynamically typed. Now you must be thinking, what is this type checking at first place? The type checking is the process of ensuring that values used in an operation are of compatible types. For example, if we have, let us say, string A is equal to hello, string B is equal to hi, and we have one more statement as print A minus B. So how type checking will work here? First, it will come at the first line. It will see that A is of type string and the values assigned is also of type string, so it will not complain here. In the second line, similar thing is there. B is of type string and the value assigned is also of type string, so no complaint here. Now on line number 3, it will see there is a minus operator and the operands are of type string and string, but this minus operation is not defined for a string and a string. So this type checking will come into picture here and will report an error here. Similarly, if we would have fourth line as print A, let us say divide by B. Again type checking will come here and see this is a string, this is a string, and this division operator is not defined for strings. So again it will report an error. Let us explore this statically typed language and dynamically typed language further. As we have discussed, in a statically typed language, variable types are checked at compile time, and in dynamically typed, variable types are checked at runtime. Also, as in a statically typed language, variable types are checked at compile time. If any issue is there related to types in the code, that will be caught at the compile time only. So the type errors are caught before the program runs. But in dynamically typed language, if any type errors are there, that we will only get when the program is executing. In a statically typed language, once we define a variable, then the type of variable is fixed and we cannot change it during the course of the program. So if we define a variable as int, it will remain int during the course of the program run. It cannot change. So a statically typed language fixes the type of variable upfront. But in dynamically typed language, if first we have defined a variable as integer, then later we can use that variable to store a string or any other data type as well. So dynamically typed language allows the type to change at runtime. The example of a statically typed language is C++, Java, and for dynamically typed language it is Python and JavaScript. Now let us go through this example to make it more clear. Let us first do these examples in the context of statically typed. So here in the first line, x will be treated as integer with value 10, but in the second line x is variable of type int, but here we are assigning a string value, so compiler will report an error here. So compile error will come at this line. Now let us look at the next example. So here also y is int with value 10. Now this plus operator is there. The type checking will come into picture here. It will see y is an integer, 5 is integer. So those are compatible types and plus is defined. So it will print the output as 15. Now in the same y variable, we are trying to assign a string value there. So here type checking will come into place once again. It will see y is an integer but the value is a string. So again here it will complain and it will give a compilation error. On this line, one more variable is getting created of type string with value virat. What will be the output of this last line? So the output of this last line depends on one more concept which we will look into once we explore these examples in the context of dynamically typed language as well. So let us forget about this last line for now and let us explore these examples in the context of dynamically typed language. So for the first example, x will be treated initially as integer with value 10. Now on the second line, the same variable is being assigned a string value. But as we have seen, in the case of dynamically typed language, it allows the type to change at runtime. So here in the second line, x will be treated as a string and it will store the value hello. So the third line will simply print the value. Now let us move to the next example. Here initially y will be treated as integer with value 10. Print y plus 5. Here also will give us 15. In the third line, y is being assigned a value 6. As we have seen, the dynamically typed language allows the variable type to be changed. So now this y will store a string value is 6. Now there is one more variable being declared str, which will be a string here with value virat. Now what will be the output of this last line? So again here the output of this last line depends on one more concept, and that concept is called weakly typed language versus a strongly typed language. We will first look into that concept and then we will get back here. So let us move forward and explore that concept. Most programming language can be either be classified as weakly typed or strongly typed based on automatic type conversion happens or not. Automatic type conversion happens or not. So if a programming language allows the automatic type conversion, the language is called weakly typed. But if it does not allow the automatic type conversion, the language is called strongly typed. Let us deep dive into this concept. A weakly typed language is one that automatically converts values between different types, which can sometimes lead to unexpected behavior. This is important. So this automatic conversion can sometimes lead to unexpected behavior. One such programming language is JavaScript, and let us look into this example to make it more clear. So this is a code snippet from JavaScript only. If you don't know JavaScript, no worries. I have just used a console.log function here, which is equivalent to print. Whatever we will provide inside this bracket, it will print this on the screen. So what do you think the output of the first line will be? So the output of this first line in JavaScript is 4. How? This 5, which is a string, gets converted to integer. automatically, and then this minus operator is applied, which results into this value 4. Now what do you think the output of the second line will be? Similarly, the output should be like this: 5 should be converted into an integer, and then the plus operator should be applied, which should give us the value 6. But this is not correct here. The output of this second line in JavaScript is not 6 but 51. What happened here? So in JavaScript, it converts this one which was integer to automatically to a string first, and then this plus operator is applied, which works like a concatenation, and it produces 51. So this is an example that automatic type conversion can sometimes lead to unexpected behavior. Now let us go to a strongly typed language. A strongly typed language does not automatically convert values between different types and requires type to be compatible for an operation to work. So here in the first line, x is an integer with value 10, y is a string with value 20. Now we are trying to do a plus operation with integer and string. So here the strongly typed language will check that the operands of this plus operator are integer and strings, which are not compatible. So a strongly typed language will report error here. If you want to make this work, you will have to explicitly either convert both of them to integer or both of them to string. So the language will not assume that you are trying to concatenate a string with an integer or you are trying to add it mathematically. You will have to specify explicitly what you want. So to make this work, you will need to either convert both of them to string. Let us first do that. String x plus y, or you will have to convert both of them to integer. So in this first case, the output will be 10 plus 20, so it will be concatenated. The output will be 10 20. But in the second case, where you are converting the y to integer, the output will be 10 plus 20, which is 30. So a strongly typed language makes sure that there is no automatic conversion, and whenever there is an operation between incompatible types, it will report an error, making sure that you explicitly tell the language what do you want. As we have seen, this x plus y will give an error if the language is statically typed. It will give the error at compile time, but if the language is dynamically typed, it will give the error at runtime. Now let us go back to the example where we left. Let us try to predict the output here. The output of this last line depends on whether the language is weakly typed or strongly typed. If the language is weakly typed, the output will be VRAT 5. But if the language is strongly typed, there will not be any automatic type conversion and it will report an error. When the error will be reported? If the language is statically typed, error will be reported at compile time. If the language is dynamically typed, error will be reported at runtime. Now let me ask you a question here. Let us say I am designing a new language and I want two properties in that language. First is bug should get caught early, And second is behavior should be predictable. What are our options? We can either make that language as statically typed or dynamically typed, or we can make that language as weakly typed or strongly typed. So what you will choose out of this statically typed and dynamically typed and weakly typed and strongly typed? Since in our language we want bugs should get caught early, and we have seen that in case of statically typed language, type checking happens at compile time. So this statically typed language is more suited for our use case. And what you will choose out of these two? As we have seen, this weakly typed language does automatic type conversion, which can sometimes lead to unpredictable behavior, as we have seen in the JavaScript example. So it would be better if we keep this language as strongly typed. So this is the case with the Golang. Golang is statically typed, which means types are checked at runtime, and if there is type mismatch, the issues will be reported at the compile time only. And it is strongly typed, which means it does not do any automatic conversion on its own. You will have to explicitly make values of an operation compatible, otherwise it will report an error. With these two concepts in mind, now we are ready to explore syntax, techniques and best practices related to variables. But that is the content for the next video. See you in the next video.